So this lesson is called literal equations, and basically it's a fancy way to say that we're rearranging equations. And we're going to take an equation and solve it for a specific variable in that equation. So if you look at my example I have here, I started with d equals, and I end up rearranging this big long distance formula is what that is, and I solved it for y2. So that's what we're going to look at. And this is actually a pretty valuable skill for people to learn, not only just for a science class where you have to rearrange equations in science, but also some business or some basic finance stuff that you may not know that you'll need to know in a future career. So we're going to look at a couple of those examples tomorrow. So let's start out pretty basic. We've got 8 examples we're going to do in this lesson, and we're going to run through some pretty quick examples, and then we'll get into some little bit more challenging ones. So let's start with example 1. If we have A equals B plus C, and we want to solve it for C, so that means that we want to get C all by itself. And to do that, we need to get rid of everything else on that side of the equal sign. So I'm just going to rewrite this. A equals B plus C. And so since C is being added to B, we are going to get rid of that plus B on the right. And so if we do that on the right, we have to do it on the left side of the equal sign as well. So then what we end up getting is A minus B on the left, and then just C on the right. And once you have it as C equals, you're all done. So that's what we're talking about with literal equations. We're just rearranging them to solve them for a specific variable. All right, example 2. If we have m equals r times t, and we want to solve it for r, well, we want to get this r all by itself. So m equals r times t. Since we're multiplying by t, the inverse of multiplying is dividing, and so we're going to divide both sides by t, and we get r equals m over t. And example 2 is done. Once we have it r equals, we're good to go. And I knew it had to be r equals because it said solve for r. All right, example 3. This is the perimeter formula for a rectangle. And so what we're going to do is solve for w. So we want to isolate that w. I'll rewrite it down here. P equals 2L plus 2W. So the idea when you have multiple things going on here is we're just going to leave this 2W alone for now. We're going to get rid of everything else on that side of the equal sign. So since we're adding 2L, we can subtract 2L from both sides. And I get P minus 2L equals 2W. And whenever you have a number next to a letter, that's implied multiplication. And so I'm going to divide by 2 on this side. And when I divide by 2 on the other side, I have to make sure that I divide everything by 2. So our answer, we're going to cancel out those 2's, is going to be W equals P minus 2L divided by 2. And you could leave it just like that. Now, every once in a while you might see it written as W equals P over 2 minus L. And so what happened there is they did the P over 2 and then the negative 2L over 2. And you can do that. And then the 2 over 2 just reduces. So you should be able to do both, but that first one is totally fine. You do not have to take it to the second answer. Example 4, we've got the area of a triangle formula here. So A equals 1/2 L times W, and we're going to solve for W. I'll rewrite it just like I did before, 1/2 L times W. And so if we're multiplying by 1/2, The way we can cancel that out is multiply by the reciprocal on both sides. So we're going to multiply by 2 on both sides. And the 1/2 and the 2 are going to cancel out. So on the left we have 2a, and on the right we have L times W. Remember, we're trying to solve for W. Since we're multiplying by L, the inverse of that is dividing by L. So we have 2a over L equals W. So the reason we do this is oftentimes you might say, well, I know the area of the triangle is 15 and the length is 10. What is the width? Well, you should be able to rearrange the equation so you can just plug 15 in for A and 10 in for L, and then you can just solve for the width. So that's something that comes up quite a bit in other science courses, and like I said, there are some business applications as well. Okay, 4 more examples. Example 5, if we have P equals M over V, a total typo here. I did not mean to say solve for X. Let's fix that. We're not solving for X. We are going to solve for M in this case. So let's do that. If I have P equals M over V, that over V is division. And so if I want to get divided by V out of there, I'm going to multiply by V on both sides. So once again, I'm trying to get M all by itself. And so the divided by V and multiplied by V cancel each other out, and we're left with M equals V times P. And there we have it. So that's it. So with this one, we needed to make sure if we're dividing by a letter, we need to multiply by that on the other side to get rid of that, or multiply it on both sides, I should say. So on example 6, it's the exact same formula, except now I want to solve for V, which is on the bottom. And so this is going to be the one we're solving for. So I'm going to rewrite this as P equals M over V. And on these, when the letter you want, or the variable you want, is in the bottom, we're going to start by getting that out of the bottom. And I'm going to multiply by that on both sides. And so the reason I do that is I can't have variables in the bottom when I want to get it to V equals. And so these cancel out, and we have V times P equals M. So far it's the same as what we did in example 5. But now, if I want to get V by itself, to get rid of multiplying by P, I'm going to divide by P. So I've got V equals M over P. All right, let's look at example 7. And really all we're doing here is we're undoing these order of operations. So we're undoing addition, multiplication, division by doing the inverse of those. So this one says solve for V, and we're going to do that. I'm going to rewrite this. T equals 1/2 times M times V squared. And this is an equation for kinetic energy in physics, and oftentimes in physics you need to rearrange these equations to solve for a certain letter. Okay, so like we did before, if this is multiplying by 1/2, I can multiply by 2 on both sides, and that's going to cancel out the multiplying by 1/2. Those are inverses of one another. So this is 2t equals M times V squared. And so I want to get rid of everything and just get it to V equals. The temptation here is to square root, but I don't want to do that right now because I have that multiplying by M. So I'm going to cancel out the multiplying by M by dividing by M on both sides. Those are going to cancel out now, and we have 2t over M equals V squared. And now we're pretty much done. We just need to get rid of squaring, and the inverse of squaring is square root. And so we end up with the square root of 2t over M equals V. And that is our final answer. So we undid multiplication by We undid the multiplying by 1/2 by getting rid of the fraction by multiplying by its reciprocal. If we had a 2 out in front instead of 1/2, we could divide by 2 on both sides, which would also work. And then we got rid of multiplying by m by dividing by m. That was our next step. And then we got rid of the squaring by square rooting. So you kind of want to work from the outside in toward that letter. All right, last example, example 8 here. So we have the area of a trapezoid. Area is the height times, in parentheses, base 1 plus base 2, and all of that divided by 2. So this is most likely something that you learned in geometry. And we are going to solve for B2. So we want to get rid of everything on that right side except for the B2. So I'm going to rewrite this one. H times B1 plus B2 all over 2. So sometimes you'll see in math or some science courses, you'll have a letter with a number subscript. And that just means like base 1 here and base 2. If it has a 0, that usually means a starting value. So if it was like n sub 0, that means it's the first, or, you know, the starting n value. Anyway, these are called subscripts, and they don't treat them like squaring or anything like that. It's not an exponent. So our goal is to get B2 all by itself. And there's a couple different things we could do to start out with. But what I want to do is I want to try to get rid of this fraction if at all possible. So I'm going to multiply by 2 because we are dividing by 2. And those are going to cancel out. So then I'm going to multiply by 2 on the other side of the equation. I've got 2a equals h times b1 plus b2. Now there's a couple things you could do here. You could distribute the h, which would be fine. Or we could just get rid of the h right now. And if you notice, this h is multiplied by all this stuff. So what I can do is I can just cancel out that h by dividing by h. So then I have 2a over h, now these h's are canceled out, equals b1 plus b2. And so now if I want to get b2 all by itself, all I have to do is get rid of that b1, so I'm going to subtract b1 on both sides. And when I do that, I get 2a over h minus b1. So that is it. Make sure that b1 is not over h with the 2a. It's kind of all by itself. But you want to just rearrange that equation, undo all of the stuff so that you are just left with the b2 there. All right, so there's 8 examples. That should get you through the homework. In tomorrow's video, we'll talk more about some real-world applications for these literal equations.